Okay. Last project of the year. So you should, let's see, I think on Wednesday we talked about doing an interior project, right? Doing, but I don't remember what I said. What did I say? Your dorm room or your bedroom or your house or some kind of interior design project. So you should get that done today at the latest and get started on, we're going to get started on our final project for a week and into the finals. And what that is going to be is we're going to be designing buildings for the city of North Platte. Let's go to YouTube first really quick. And to do that, we're going to use Google SketchUp to design these buildings, and then we're going to print them using a 3D printer. And during this project, you are going to be required to keep a project logbook. With anytime you work on your drawing, you should save that drawing to your logbook. So you should use a logbook inside of Microsoft Word or Google Drive or something like that. And then once you've got the design of your building finished, then you will be converting it into a file that can be printed on a three-dimensional printer. So let's learn first of all about three-dimensional printers. Let's go to 3D printing and let's learn about it. Yeah, I'm bringing it up here. Hold on a second. All right, it should come up now. So let's take a look at this one here. This is a video made by the company that makes the 3D printer that I own, that I purchased. It's a printer called the MakerBot. It's called the MakerBot Replicator. And they have two of them actually. They have two replicators. They have the original one, which is like the one I have over here on the right, and then their newer one, which is much better looking and actually performs much better as well. And they're gonna kind of tell us all about these three-dimensional printers, how they work, and what you can do with them. So off we go.
Norm 3D printing. 3D printers. 3D printing with 3D printers.
It's a real deal. We were early on 3D printers.
Yeah.
And since then,
That's a very sped up video, by the way. That was their first printer that they ever made, called the MakerBot, that they were showing just there, and the printing is extremely sped up. It doesn't print nearly that fast. So they're showing it to you probably about 5 times speed or something like this. Anyway.
Except for the very latest, most recent experimental Replicator 2, yeah, I spent a lot of time printing stuff over the last 3 years.
And there may be a lot of misconceptions of how easy 3D printing is or how difficult it is, and we just want to explain the whole 3D printing process and give people an understanding of what that means.
Kind of a brain dump, both about the basics of 3D printing and then specifically like what you get when you spend $2,200 on a Replicator 2.
So watch this video if you've never done any 3D printing before, and even if you've done some 3D printing and maybe you've shared some of our experiences, and you can learn some give us feedback.
So the first thing we should talk about is what actually 3D printing is. It's a really simple process. Basically, you have a couple components that work together. The main one is this thing called an extruder, and all it is a motor with a gear that takes plastic in the top, heats it up to the melting point, and then spits it out the bottom, usually in a very controlled manner. So you use what's called a stepper motor, so you can control the speed at which the plastic moves through. And then there's another thing called a carriage. The carriage is very similar to a normal paper printer in that it moves that print head, the extruder head, back and forth across a two-dimensional surface The only thing that really changes between this and, say, a printer that uses paper is that this also has a Z-axis, so it can lift up and lift up and lift up. So it can apply a layer of plastic, lift up a tiny amount.
Okay, so the funny thing is they're saying that this platform lifts up, but it actually is going down. The carriage that holds these printer heads is kept at a constant height, and as it prints each layer of this, whatever it's printing, the platform moves down a millimeter or so each layer.
Amount is typically the vertical resolution of the printer.
And
Lay
here this is about 10
another layer
times
of plastic
speed.
down, raise up, another layer of plastic down, raise up, and so on and so forth.
So there are many analogs to a traditional regular paper printer or laser printer.
It's a lot of the same technology, except for a normal 2D printer is a one-dimensional printer, basically,
Where you're only
and you
moving
spool
in X or Y, where the print head is moving maybe across one axis and the paper is moving across another axis.
Exactly.
Here, the print head, at least modern 3D printers, move both in X, Y, and then the Z is where the surface moves.
The Z is the equivalent of the paper in this case, because the Z only moves one way. You start at the bottom and work your way up,
Looks like
or in some cases you start at the top.
Washington Monument.
So right now, with modern 3D printers, you can print plastic.
Yeah, so there's a bunch of different materials you can print. The most common are ABS plastic and PLA plastic. ABS is a normal. Actually, the blue stuff over there is ABS. The melting point of both of these is around 200 degrees Celsius. So double the boiling temperature of water. And they have different properties. ABS is a little bit more difficult to use. It cools slower, which means that it has a tendency to shrink as it cools, and that causes an effect that we call warping, where basically the edges of a print will kind of curl up if you do something big or if you don't have the platform heated. That's why the Replicator 1 over there, the wooden printer, has a plexiglass case around it.
Yeah.
That helps insulate it from, like, a cool breeze from the air conditioner can have a negative impact on your print when you're dealing with ABS. It's also a little bit more toxic. It produces fumes. The material sheet on it says that that's perfectly safe to breathe the fumes. I find that when I do a lot of ABS printing, I get a little bit of a headache at the end of the day, which probably means it's not really good for you.
So to recap, the major components of a modern 3D printer is the print head with the stepper motor, and then the carriage.
That's the thing that holds the print
holds
head.
it and moves in different axes.
Although sometimes the platform, the thing that you're printing onto, moves underneath the print head.
Right,
so it's like there's a bunch of different ways to do it.
A carriage, a build platform, which is that surface, and that kind of determines, combined with the carriage, the size of the object you can build. And in terms of the MakerBot 1, that is a heated build platform.
Yeah, so the reason you use a heated build platform is either for adhesion, to get the material to actually stick to the platform, or to help reduce warping. So, I mean, there's two different ways. The Replicator 2, the base Replicator 2 has, I think it's like a plexiglass or polycarbonate or something, acrylic. Build platform. It's not heated. The Replicator 1 has a heated build platform. The experimental Replicator 2 has a heated build platform. And that also adds a lot to the energy that's used. The heated build platform has a pretty heavy thermal capacity, so it takes a while to warm up, and it takes a fair amount more energy to run.
And really, and then you talk about the materials, ABS plastic and PLA, which...
PLA is the other, this is the big enhancement. It's a corn-based plastic. It comes in a variety of different colors. And the benefit of it is it cools much more quickly than ABS, so warping is less of a problem. It also comes in some interesting colors, like that translucent blue, I think, is really pretty, it diffuses light in an interesting way for things that don't really shine light through. Right. The other benefit of PLA is it's corn-based, so it's non-toxic.
And then, with both types of plastic under material right now, within the stepper motor that is heated and melted, from spools, so the material you buy in spools.
Yeah, so the extruder is really, really simple. It is literally a hot end, a thing that gets to 200 degrees Celsius, a motor with a gear on it that grips into the edge of a piece of spindle plastic and pushes it down, forces it down to that hot area. So what that does is reduces the amount of plastic that comes out at any given time from like a 1.75 millimeter, which is the diameter of the plastic going in, to 0.4 of a millimeter.
And that determines the quote-unquote resolution of your print.
That plus the vertical resolution of the Z-axis.
How far up
and
down the build platform moves per each row.
So the theoretical maximum resolution, and this is a smaller is better situation, for both of these printers is 100 microns or a tenth of a millimeter. So it's a very, very thin resolution. It's about the thickness of a fairly thick sheet of paper. And you can see the difference here. This is a difference in quality really good. This is, as you can see, it's an R2-D2 head. The one on the left is a 0.27 millimeter resolution, which is the medium setting for the Replicator 2. We'll talk about that stuff in a minute.
And for this type of build, you can actually see all the lines very clearly.
Absolutely. It's a rough sketch. Is the analog I would use.
And then when you get something much finer, the finest that the Replicator 2 can do today,
or the Replicator 1,
or the Replicator 1, then it's much smoother, but you can still see lines.
Yeah. So before we move on from the plastic, you can use PLA in the Replicator 1, or you can use ABS. As long as you have a heated build platform, you can use ABS relatively easily. It's difficult to use ABS on a non-heated build platform, especially for large stuff. So that's the big difference. That's why the Replicator 2 is a PLA-only machine, and the Replicator 1.
And in terms of temperatures, 220 degrees?
220 for ABS. PLA melts anywhere from 180 to 210. It starts to scorch if you get much above 230.
And then the build platform, if you're using a heated build platform, how hot does that have to be?
It depends on the plastic again. So for ABS, you usually run at 100 or 120 degrees Celsius. For PLA, some people recommend running at room temperature. I find if you run it at 60 degrees, then it makes it very easy to break the model loose when it's done. So that's important.
So that pretty much covers the hardware side of a MakerBot.
I mean, there's electronics and stuff like that that makes all the
controllers
and there is a controller inside which has an SD card reader. And basically, the way these machines work is you take a 3D model, typically an STL file or an OBJ file, or you can use most 3D CAD packages to render out one of those two formats.
And these are standard formats.
Fairly standard formats.
The STL file, whether it's on a MakerBot or some other 3D printer, you start with an STL file.
Exactly. So that is a 3D model. It's not sliced. So once you have the 3D model, and you can also so you can create them yourselves using a program like SketchUp or AutoCAD or 3D Studio Max, or even free stuff like 123D Design or 123 Capture and all that stuff.
Once you have an STL file, you said not sliced. Now, the word slicing is important because in terms of a 3D model, it's a 3D model printed and sliced in many layers. Yeah, so
once you have the model, you ingest it into a program called, well, I call them slicers, I don't know what the technical term is. There's a handful. MakerBot provides...
I'm actually going to go back here just a second.
The word slicing is important because...
So once you have the 3D model, and you can also so you can create them yourselves using a program like SketchUp or AutoCAD or...
I want you to notice this part. Here he's got a little Tetris game in a 3D drawing program, and you can see that he's obviously trying to move this piece into place right here, right? But notice how difficult it is for him. He tries to move it into place, he thinks he's got it in place, but then he sees it's not. So he tries to move it again, and then he has to rotate it to find out that he's not in the correct place. And he may end up having to rotate it 2 or 3 times before he gets it into the right position. That's essential when you're dealing with 3-dimensional drawing. You need to rotate and change your perspective all the time to make sure you know what you're doing. Otherwise, you're going to end up with chairs hanging off the wall, and your ceiling, is crooked, and you have all kinds of crazy things going on that you can't see from one perspective, but you will notice as you change perspective. So make sure that you are changing perspective as you design in Google SketchUp, so that you can see what's actually going on. So that was just a good example of that.
It's a 3D model printed and sliced in many layers.
Yeah, so once you have the model, you ingest it into a program called, well, I call them slicers, I don't know what the technical term is. There's a handful. MakerBot provides Makerware, which is their own closed source internal tool. It's very easy to use. It's relatively fast at the medium settings. It gets very slow at the highest quality settings. And there's not a whole lot of knobs and dials to turn. Because when you're dealing with this slicing process, let me explain what the slicing process is. What the slicing process does is says, okay, you have a model that you want to be 400 millimeters high, and you want the vertical resolution to be 1/10 of a millimeter. So that means you're going to need 4,000 layers. My math is right.
Yep.
And each layer has a toolpath that's defined. So on each layer, the slicer says, okay, the printer is going to start here, and then there's going to be a 2-dimensional line, or maybe a series of 2-dimensional lines that move that stick to the layer below, and will provide the base for the layer above. And it literally defines, it says, okay, start at this coordinate, go here, then go here, then go here, then go here, then go here. Sometimes millions of times on a big complex print.
And it's smart enough to know that when you're building a volumetric object, the layers obviously are not solid for every layer.
You can make it solid. That's a little tricky.
Then you're using a lot of plastic.
And it'll take a long time.
And it'll take a long time. But what you want to do is use the algorithms to be smart enough so that it's solid where it matters, and then it builds enough of the structure inside. So that when you add those layers up, it is a solid object.
If you built your model properly, then it should, the software, the slicer should know what should be filled and what should be hollow. So for example, this guy, the lamp, show the lamp. Or actually, show the White House first, that's good. Yeah. So this is what the inside of a model looks like. This one, it broke loose mid-print and it skipped, but if you pull off that top layer of cruft there, and it's just a grid. There's a bunch of different grid patterns it can use. Makerware has some that it uses by default. Typically it's hexagonal or square, sometimes triangles. And what this does is, as the plastic's coming out, if it doesn't cool fast enough, if it doesn't have something to rest on while it's cooling, then it'll kind of sag and make something that looks like a little bit like droopy spaghetti. It's kind of sad. So this internal structure is a function of the software.
Right, and it's mostly the same between the layers, but you can tell that it's denser on the edges because that's where it's supposed to be solid.
Yeah, so there are several variables when you're doing the slicing that are really important. Infill percentage, which is what that is, that's probably about a 5 or 3% infill, and that's just the total amount of interior volume that's filled. The number of shells is the number of outside layers, so the space between the inside of the model and the outside of the model. And changing that can affect both the kind of fine detail on the model as well as the thickness and how sturdy the overall model is.
Okay, so you have an STL file.
Yeah.
You run it through a slicer.
Yeah.
And these are free tools that you can download.
Some are free, some are paid for. There's Makerware is MakerBot's own. It's very simple and easy to use, but not particularly powerful. SkyneForge is the open source version. It came with previous MakerBots. It is very powerful, very difficult to use. And then there's other things like Slicer, which is SLIC3R, and there's a couple others.
Which one do you recommend?
If you're just starting out, then Makerware is great. It's an easy way to learn. You're not going to get really good, high-quality prints out of it, I think. We can talk about that in a little bit, but it's great at the 0.27 millimeter resolution. It's very fast. They use their own custom proprietary slicer code that is much faster than the SkyneForge default. When you go up to the 0.1 millimeter, 100 micron resolution, then it gets very slow and it actually uses SkyneForge.
And when you're saying very slow, you mean the actual computing and running the program.
So generating those tool paths and figuring out how many layers there are and what the layers look like as it's printing is a really complex problem, especially for a big, complex model. Right. It can take, for example, that R2D2 head, I think for Miracle Brew, the Makerware specific one, took maybe 5 minutes to run. For the 0.1 micron resolution, took like 2 hours. So it is a big, big, big jump in time, sometimes even a couple of orders of magnitude. Right. You get better control and better results. Unfortunately, Miracle Brew can't do 0.1 millimeter resolution right now. It doesn't do it very well.
And so when someone like Chris Anderson says, you go to Thingiverse, you download Dolph House Furniture for your kids, it's not like you press download and then send to printer. You press download, there's a little tweaking, and then you have to slice it, and then you put on an SD card and then put it in the maker. So,
yeah, the thing that happens is you develop a feel over time for what the different settings are. You can kind of, once you've gotten used to it, for example, if you take those chairs out, we have 3 of the wingback chairs, and I don't have the legs on a couple of them. But if you look at the seat of the 2 small chairs, one of them isn't filled. There's gaps in the one on the left. There's not gaps in the one on the right. Those horizontal lines on the seat of the chair are actually holes because I didn't have enough shells on that particular model when I was printing it.
And this is just configured in the slicer software?
You configure it in the slicer software generally. Like I said, the difference between SkyneForge and, say, Makerware is that SkyneForge has literally a couple hundred options, and Makerware has maybe a half dozen.
But then when you take a 3D object and you download it, you can also do something to scale it.
Yeah.
You can configure that too.
So yeah, the different software has different options. Makerware is probably the gold standard in this. It lets you scale to a specific percentage, so you can maintain the scale that you want, or you can just kind of eyeball it or make it as big as the machine will print or whatever you want. You can also place multiple things on the build platform. So this is a long process. printing something like that chair or like this lamp in front of us, literally that lamp took 8 hours to run, the two pieces. So I was able to put both pieces on the print platform at the same time, and they were able to go in a, so then I could leave the machine and it would print unsupervised basically. The R2D2 head at fine resolution took a very long time because I had to run it at a very slow speed.
Okay, so you practice a lot with the slicer.
Yeah.
Okay, so that whole section where they're talking about this slicer software is extremely important. When we build a model, we can close off the model so that it is a solid model. In other words, it has no open space, has no open path to the inside. And that's absolutely essential for making one of these three-dimensional prints, that your model of whatever you're doing has no openings to the inside of the model, and that it's a closed-off object. Once that object is closed off and you put it into one of these slicers, the slicer looks for the boundaries of the object or the boundaries of the drawing you've given it, and it assumes that everything inside those boundaries is solid, and then it slices it up into the layers that it's going to print, and it starts to put together a tool path. So it starts to organize which directions at what time the printer head is going to go and squirt its plastic. So that's what they've been talking about there. Anybody have any questions so far about this three-dimensional printing deal? Okay. Yes.
When we make our models, does it matter the scale in the program for printing the object?
No, you can scale it down after you're done making it. You can scale it any way you want, and then you can scale it down when you're doing the slicing.
Okay. Just didn't want to make a 30-foot print.
Depending on which one you've used, and then
Couldn't do it
you
anyway.
put it on an SD card and you put it in your
So-
little 3D printer.
What the slicer spits out is a text file or a binary file that contains G-code. G-code is a kind of a universal descriptor for CAD/CAM machines like this. So it basically says, here's the start point, here's the end point, here's what you do at every step in between. Move the x-axis this far, the y-axis this far, go this rate, all that kind of stuff.
G-code applies to most CNC.
Yeah, you use it on the $2,000 MakerBot or on like a $250,000 Tormac CNC mill.
And that is the big breakthrough in 3D printing, having G-code. In terms of CNC, when you think about old printers, and old printers had different protocols.
That is definitely true, yeah.
Now everything, because it interprets the G-code, that's the standard.
So the way to think about this that's important is the G-code is basically even though it is a universal, a common language, there are specifics that are specific to each machine. When you make a piece of G-code, theoretically I could run the same G-code on the Replicator 2 and the Replicator 1. It's not.
Now, don't be intimidated by this. You don't have to do any of this programming. The computer all this is telling the printer head where to go each step of the way. So each one of these lines is essentially a beginning point for the printer head to go. And the slicer writes the code for you when you upload your object. So you don't have to be intimidated by all this talk about code.
Your STL is a universal file. The G-code is specific to each machine, because the slicer has to understand the capabilities of the printer in order to make the optimal tool path for that printer. If the resolution of the nozzle at the bottom of the extruder is different on one printer than the other, then that's going to impact what the finished result looks like, and you have to account for that when you're doing the slicing. So,
for someone who's casual in 3D printer and just got through the point, where are the ways that 3D printer can break down?
There's a bunch of ways.
Let's go over because some of them.
Okay, so the basic stuff is that the print head can get clogged. Mm-hmm. If you leave it hot for too long, especially with PLA, the plastic breaks down, and you end up with a big goopy blob of plastic coming down out of the printer. That's gnarly. Right. Other stuff is like the print bed on the Replicator 2, at least the one we have that's a loaner from Atom.
The platform.
The platform is wobbly. And when you're talking about a tenth of the thickness of a piece of paper, having a wobbly print platform, it's not acceptable. It's not good.
Calibration is needed.
Makes
almost
it
regular maintenance.
It's regular calibration.
Yeah.
On the older model printers, like the Replicator 1, which has a bolted down to the bed print platform, it's much more stable.
You set it once and maybe you tweak it a couple times.
You may adjust it for specific things.
Right. But it's not like week to week where
Every 3 or 4 prints. Every time. The other stuff is things like the adhesion to the surface is a continual challenge. So getting the plastic to stick, that first layer of plastic to stick to the model well enough that it doesn't break loose during the print, but does break loose when you're done printing, is a kind of fine balance. On the Replicator 2, I use blue painter's tape, which is what they recommend. A lot of this stuff is in the documentation, some of it's not particularly well documented, but you have to wipe off the blue painter's tape with rubbing alcohol or acetone to get the finger oil off, because the oil from your fingers from touching the platform is enough to make the plastic not stick very well over a 6 or 7 hour print.
And then they can warp on the bottom and just shrink differently.
So a lot of these problems are interrelated. For example, if your build plate isn't level or it's too close to the print surface, then there won't be enough room for the plastic to squeeze out, and that'll cause the filament to strip, and then plastic will stop coming out, and you end up in a situation where something stopped working. It's the same exact symptoms, but there's 15 different causes for it potentially, and it's really hard to troubleshoot, especially if you don't have experience with it.
It's very time consuming.
It's very time consuming. The price of failure is really, really high.
You could spend a couple hours
slicing,
and whether you don't know it's going to work.
Yeah.
And then you got to print, and that could be a point of failure.
Yeah, I mean, the printing is most likely where you're going to determine the failure.
Right. And that could take 10 hours.
So this is absolutely true. Of this entire process, the printing takes at least half of the time of the project. So if we have a week plus a couple of days before the end of this semester, you should have researched what you're going to build, or design rather. You should have put together a design and sketched it, and have it completed and sliced and ready to be printed within 3 days, maybe 4. And if you don't have it done by then, it's almost guaranteed it will fail, because there are so many things that can go wrong, and every time something goes wrong you have to start over again, and sometimes you have to go back to the design phase. You can't just start the print over again. Sometimes the print just won't work the way it's been designed. So be aware of that.
Yeah, so if you're looking at something that takes a couple hours to slice each time you want to try it, and then another 7 to 10 hours to print, then you get maybe 6, 7, 8 chances at that a week, even if you leave it running overnight.
Right.
And it may get 90% of the way done, and then bomb out in the last 3%, which is what happened with the lamp. If you look at this, the top is very clearly not finished, flip it down, and what happened was it broke loose from the tape, it warped a little bit on the bottom, pulled off of the build platform, and we ended up with the plastic pubes that you have over to your left. It just went crazy because I left it running overnight. You can iterate very quickly with small, simple stuff, but you can't iterate very quickly with big, complex things. And the place that it breaks down is printing large stuff. If you're printing things like
Physically
the chair,
large, not complex, but physically large.
Yeah, so if you look at the ABS, the game pieces and the chair and stuff like that, that all looks great. If you're looking at things like the Tetris pieces, which I use to prototype my shelves, then they're very simple and were very fast to print, but it was incredibly useful because I was able to see what I wanted the shelves to look like in the end before going in there.
But if you're doing something that's complex
things,
that has mechanics.
Yeah, pre-assembled gear systems and stuff like that. I spent hours trying to get this to print. This was the result of about 2.5 days worth of work all told. And it works. It's amazing. That was printed all in one piece, and it is by far the coolest thing we've done. It's a planetary gear system. It spins up at full speed. It's high friction, but it's a round bearing that works, and you can 3D print it. I think that's really cool. On the other side, I printed things like watch bands that were highly questionable and didn't work very well at all. And then I've also printed things like the bottom of the lamp that were completely failed. So you have to be ready to experiment. You have to have a lot of time. If you don't have a lot of time, then maybe 3D printing at this stage probably isn't.
It's an investment not only in the initial investment, because a MakerBot can cost $2,200 just for one print head.
Well, so there's many cheaper options available.
As cheap as $500, $500 to $600.
Yeah.
But then you're spending even more time, like we did with the second generation MakerBots. in terms of troubleshooting?
The guys at Make did a 3D printer special last year and tested a whole bunch of different printers. And I know that there are some good options in that $500 to $1,000 range. The thing that's changed is that the software is much better now than it was 3 years ago when we started. So there has been, I don't want to sound like we're down on 3D printing. It is much easier to get into 3D printing today than it was 3 years ago.
Yeah.
It's both cheaper and the software is better. Even the complex software like Replicator G is much easier to use now than it was before.
You're not building your own extruder and stepper.
Exactly.
It's taking a day or a week to do that.
When we built the first cupcake, we got essentially a flat pack 3D printer and had to assemble everything from the chassis to the extruder head to the build platform.
You can still
motors,
do that
electronics,
now.
all that stuff. Oh, absolutely.
If you want.
And if you're buying a $400 printer, that's what you're going to do.
But you can also spend 4 times as much and put something.
So this is information for your high school teachers. If they're interested in getting their own 3D printer, they can buy one and build it. I believe that MakerBot still does that. I'm not sure, but I think they still do. But there are other companies that do as well.
They'll come out of the box and just count.
Well, I think that's a little unfair, though. I mean, I think the promise of out of the box, easy to print is kind of true with the Replicator too. In reality, though, I don't think it's a fair thing to say, and it sets an expectation that people shouldn't have. And again, this is still something you're going to spend some time on.
It's not an HP printer.
Yeah, it is not. Take it out, load it up, put the ink cartridges.
But that's something
in,
that 3D Systems wants to be.
I think
locked in cartridges and ways to cut off the cruft.
I mean, that stuff. So the difference here is that you can take the SD card that they provide, jam it into the machine, and print the sample stuff, and it'll probably turn out okay if you lucked out and do a decent job leveling the build platform, and your tape is on level, and there's no overlap between the different sections of tape, and there's no bubbles or anything like that. You're not going to be able to do that at the highest resolution. They advertise that the default for printing is 1/10 of a millimeter, and that's nonsense. I mean, it takes literally a couple of orders of magnitude more time to slice an object at 0.1 millimeters than it does at 0.27, which is the millimeter default, and is actually the default of the software that they ship. The quality is commensurate with that. I mean, it is twice the resolution at 0.1 microns. It takes twice as long to print or more, and it looks a lot better. But you're not realistically printing stuff at 0.1 microns. That is an advanced move for advanced users. And it's very slow.
Still it's a hobbyist business right now.
I think it's for people who, if you need a 3D printer, you probably know. Like if you are, I think there's a couple of really good use cases. I think Chris Anderson's print your dollhouse toys use case is great.
But he probably don't buy it for that.
I think, if your kid is really into that stuff and you can get a $400 or $500 printer, the difference between the cheap printers and the expensive printers is support and the size of the print area.
Support
the resolution
from the company.
Support from the company. The size of the print area is if you're printing dollhouse furniture, the $400 machine is great. The resolution is going to be roughly equivalent, depending. You can pay attention to that. The MakerBot is 0.4 millimeters. Some are bigger, but most are about that, and they use the same size filament, so that's not a problem. I think that's a great use case. It's a good way for a kid to learn how to do 3D modeling. This is a great educational tool, because if you're 12 years old, you're really into building stuff in 3D CAD programs, and you're into learning that, this is a gift that keeps on giving, right?
The software will keep on getting better.
The software has improved dramatically in the last 6 months.
Makerware works with the old Replicator.
Yes.
And hopefully future versions will also work with the existing models.
It should. If you want to build this to build machines, it requires a much greater level of precision from the software and from the hardware. If you need to really understand how the machine works, you need to really dial it in. You're going to end up spending hundreds and hundreds of hours getting it to the point that you can print something like that over your system. It's a pre-printed mechanical assembly. If you're an architect or something like that, this is an okay thing to use to build your models and stuff like that, rather than coming out of foam core. Although you might not get the quality that you want out of this generation of device.
So the MakerBot Replicator 2, it's an amazing piece of technology, but
I wouldn't buy it.
You got to really need it.
Yeah.
Be willing to spend the time with it and be able to afford it.
I mean, I think if we were looking at $1,000 versus $2,200 or I think $2,800 for the ABS dual head model, it makes much more sense. This is something, if you have a business need for a 3D printer, then you can do it. if you want something to noodle around with at home, buy one of the rep wrap kits, buy one of the either cupcake or thingamatic variants, and go nuts with that. You'll have a much better experience. And you'll optimize it.
Awesome. Well, we'll find more about 3D printing, 3D printers, and the MakerBots.
We do 3D printing every week.
Every week?
Yeah.
Okay, so that is a general overview of 3D printing with the MakerBot. Some of you have probably heard of 3D printing of guns. That seems to be a very popular topic. Sure, it can be done. It's not worth being done because the gun that you would make would be able to be shot once. Anybody could make a gun that shoots once. And besides that, you'd still be able to see it because the imaging devices, the X-rays don't go through things like most people think, is I guess what I'm getting at. X-rays diffract off of all objects. And so any object of any shape, made of any material, can be seen by an X-ray. So you're not really helping yourself unless you disguise, it's some other way. Anyway, nothing to be worried about is what I'm saying. Nothing to worry about people printing off guns and sneaking onto airplanes. People will sneak weapons onto airplanes without that. They won't need to. So you can be afraid in that way. Guess that didn't comfort anybody. But there are much more advanced three-dimensional printers. I want to see if I can find one here for you. Here are two others that are very similar to the, actually there's three others that are very similar to the one we just looked at. Let's look at, there are essentially two types of 3D printing. The first one is where the material is squirted onto a platform like we just saw. The other one is where you print into a powder. And so let's see, here we go. This is a company called Z Corp. And they make really expensive 3D printers up
now
to
create full-color
$30,000
3D models more quickly, easily, and affordably than ever, right in your office. Introducing the Z Printer 450. The Z Printer 450 brings CAD files to life as realistic physical 3D models with precise detail and brilliant color, and does so 5 to 10 times faster than other systems at less than half the cost. Dramatically present the proposed look, feel, and style of product designs and prototypes, vividly display architectural visions, and better communicate 3D information in education, healthcare, and the arts, all in ways that electronic displays cannot. The first automated 3D printer, the Z Printer 450 is remarkably easy to use and very office-friendly with clean, quiet operation. And it's from Z Corporation, the industry leader in color 3D printing technology. The Z Printer 450 is for those seeking high-quality color 3D models, plus the convenience of an in-house printer to build those models anytime, anywhere. The uniquely automated Z Printer 450 simplifies the entire 3D printing process. Self-contained and self-monitoring, it manages nearly every aspect of printing, cutting user interaction time by 40%. Simply import your 3D data file into our Z-Print software, position as desired, and follow the prompts. The system automatically checks supplies and printer readiness, ensuring you always have the right amount of materials to complete the job. If supplies need replenishment, it's as easy as inserting a 1-liter binder cartridge, connecting a powder canister for automatic loading, or snapping in a new print head. When ready, click 3D.
So you can see that those are using quite a few different things to print with, right? And you saw 3 different things there. You saw the big bucket, and that's the powder. And then there was a cartridge that he stuck in the side. That is actually a binder, kind of like a glue or an epoxy. And then there was a print head, which was actually the color. And so they have a big thing of powder that they inject glue into to make the powder stick together and ink into to give it color. And then they heat the entire object to let it set, kind of like almost like a ceramic.
Print and watch your 3D model emerge from the bottom up, one cross-section at a time, in 450 dpi resolution. Advanced inkjet technology builds models 5 to 10 times faster than other rapid prototyping systems, so you get your model in hours, not days. When printing is complete, a vacuum and motion system automatically removes up to 80% of loose powder and recycles it for future use. Removing the remaining powder is just as easy, using lightly compressed air in an enclosed chamber that vacuums away particles as you go. Plus, with no physical support structures attached to the model, like other printers, you can say goodbye to dangerous scraping tools and chemical baths. Every 3D model emerges clean and ready for finishing with one of 3 processes that vary surface finish to match any application. Choose a quick dip in Z-Bond sealant followed by a short drying period. Get the same effect by dripping Z-Bond over the model. Or lightly brush with Z-Max Infiltrant for a strong, brilliant color finish. Regardless of which you choose, you get a smooth
So you can see that this idea of 3D printing comes in all kinds of shapes and sizes, from a very advanced printer like this. That printer, I think, goes for about $50,000, $100,000 maybe. And the materials for printing cost a lot more. And my printer, which I think I bought with a bunch of materials for $3,000. So lots of different levels. And of course, the people that are using these other printers, these things can print machines that have moving parts already moving in them. For example, this part right here is probably a spring, and it probably behaves just like a spring. And if this thing over here rotated, it probably will rotate in this design that it's printed in. And if these screws are intended to thread in and out, they would thread in and out. You put a screwdriver on, you could take them out, and you wouldn't even have to do anything special. They would be printed right into the socket with threads on them, and they could unscrew. It's really quite amazing what can be done with these new 3D printers out there. And the materials can be quite strong as well.
And you get it fast. In fact, from start to finish, this model was printed, depowdered, and finished in under 4 hours.
Look at the detail in here. You have a spring in here. That spring is not necessarily just printed onto this gray sleeve underneath it. It may actually be separate from it so that it can slide over. You can actually take it out. It just depends on how they designed it. So all these parts that are different colors could very well be parts that could be taken apart after the print. Something that my printer cannot do, doesn't have the resolution. You can see here, you can't see the printing lines in this. The printing lines are extremely fine. So it's a very high resolution print.
Best of all, the Z Printer 450 is incredibly office friendly. With a small footprint, negative pressure dust control, noise suppression, and zero liquid waste, it's just like any other printer in your office. Everyone can afford to create 3D concept models, functional product prototypes, architectural models, and more, and do it all in-house. It's fast, it's color, it's easy to use, and it's available at a breakthrough low price. It's the Z Printer 450 from Z Corporation. Full-color 3D printing whenever you need it.
So when they say breakthrough low price, tens of thousands of dollars. I think the cheapest one made out there is made by this company, and it's not that one. It's a much smaller one. It's not color, and it's also not a powder printer. Well, it is a powder printer. I think the cheapest one is around $15,000. Very small, very slow, and not very high resolution. But anyway, it comes in all kinds of shapes and sizes. They even have one that will print in a metallic powder, so that you can print something out of metal. It's not steel, it's more like a die-cast brass. And it's not really a solid piece of metal. It's more like a glued together piece of metal. But they have done it, so it's kind of interesting. So now, what is the project? The project is to design a building that we're going to put on the map in our on the 3D map here for North Platte. You're going to have to keep a logbook the entire time you're working, and you need to keep track of drawings. And so when you're in Google SketchUp, you can actually print off a picture of your drawings. You can do it a couple of different ways. You can save the drawing as a PDF and then just print the PDF, or you can print it directly to paper. And that's one thing to do it, but I would save it as a PDF and then put it into your, just save it into your logbook. You can also print it as a picture, like a PNG file, PNG, or a JPEG file, and then you can put it into your logbook that way. But every time you work on your drawing and you change something, I want you to save a version of it, like save it as a JPEG and put it into your logbook so I can see what you did that day. Your particular building, the building that you will work on, I will email to you. So each one of you will have a different building to work on. I will email it to you what the building is and a picture of it, an image of it, and it's actually not all of them are buildings. So anyway, but your job is to be able to model it in Google SketchUp as the best you can, with as much good detail as you can, and then be able to put it into a file that can be printed on the 3D printer, and then to actually print it. You'll send me your final design by the end of next week, and then I will, actually not by the end of next week. You'll send me your final design by Wednesday of next week so that I can try to print it, and if there are things that go wrong because of the design, then we will print it. We will change that. So, as far as the slicing goes, I will show you how to do the slicing probably next Monday or next Wednesday, and I will show you the program that is used for that, another program that can be downloaded for free. And besides that, just await my email. I'll send you an email today with your buildings. Any questions? Okay. If you haven't finished your interior of house assignment, interior of room assignment, whatever it is, please do that. And make sure that you send me the SketchUp file by email. And have a great weekend. We'll see you later.